Welcome aboard the Durflinger. I am your captain, the Kamarsh, and today we will be doing base conversions. So we have a couple different choices here. We can either convert from decimal or to decimal. That's basically the main two ways we're going to be doing it. And I will start off with the shortcuts first, and then if you guys are interested, then you can go ahead and continue on with normally how it would be taught. So a shortcut for converting from decimal to binary is by looking at the parity. I'll go ahead and get that in a bit. And then, of course, the longer way is by remainder, but remainders suck. So, yeah. If we're converting to decimal, then normally we would look at the weight being the powers of whatever the base. Or we could do it by table, which is pretty much the same, but it's a little easier, I think. Alright, so we're converting decimal to binary. So what we're going to do is we're going to go ahead and divide our number by 2. And then we're going to look at the parity of the dividend. If the dividend is even, we apply 0. If it's odd, we apply 1. So as you can see here, we just keep dividing by 2. We don't care about the remainder. That's the awesome part about this. So 171 divided by 2, 85, 85 divided by 2, 42, 42 divided by 2, 21, and 21 divided by 2, 10, all the way down to hit 0. And then what you want to do is how you read it is you read it from bottom to up as far as writing it down. And then you read it from the most significant figure to the least significant figure. Next. Ooh, decimal to binary. With remainder. So, remainders suck. There's 2 ways to do by remainder. Usually by, it's more natural if you do long division, because the remainder is just going to be there just by repeated subtraction. Or you can divide like this and then get fractionals. All you have to do is just multiply the fraction part by the base, and that's how you get the remainder. And the cool part is that your amount of options for what the remainder can be is limited to what base you're working with. I think. I could be wrong, but from my testing, I think that's the case. So, like normal, 342 divided by 2, 171 even, 171 divided by 2, 85 and some change. And then 85 divided by 2 is 42.5, 42 divided by 2 is 21.0 even. So multiply that base by the fraction part, you get the remainder. Alright, now let's move on to hex, decimal to hex. So, same thing, go ahead and divide 379 divided by 16, you get 23 and some change. Go ahead and multiply that change by 16, you're going to get 11. Now, as I said previously, I think that the amount of let me test this real quick. I'll probably end up restarting this recording. So 16 divided by 9999 something. Okay. Oh well. If I'm wrong, just go ahead and point it out, and I'll not re-record it. It's on my 3rd attempt. So go ahead and divide 23 divided by 16, 1 and some change, multiply the change by 16, you get 7. And then divide 1 by 16, it's 0 and some change, multiply change, you get 1. Now do remember that numbers past 10, all the way to I think F, or rather 15, are represented with letters of the alphabet. And so for 10 it's going to start at A, and then F is going to start end at 15. That's a little something easy to memorize. Ooh, by table. Alright. So now we're getting into converting different bases to decimal. It's pretty much the same as converting with weights, but I think a table representation is a little easier. So what we're going to do is we're going to go ahead and lay out our powers of 2, and then after that we're going to go ahead and place each digit in their respective powers of 2 place. And then all you have to do is just add up the ones that have 1 in it. And so, for example, if we want to go ahead and convert 11001000, we go ahead and do 128 plus 64 plus 8. And then we get 200. Next, by table nibbles. Alright. So, this one, I went ahead and decided to convert from hex to binary to decimal. Because why not? Starting off here, we have C. And if you remember previously, C is like 12. And then, of course, you're left with C and 8. And then convert that to binary. And you can do that by using parity or remainder, whichever one. And then go ahead and smack those two numbers together. And then you get a giant 8-bit binary number. And then rewind, go ahead and place those inside your table there. Add up the ones that, add up the powers of 2 that correspond with 1, and you get your number. Next, hexadecimal to decimal. This is by weight. So this is typically how most professors, I think, would teach this. Basically, all you do is you start from your base to the power of 0. And then you multiply each digit by that base to the power of whatever in an increasing order. So, for example, we have hexadecimal number 72. We're going to multiply 2 times 16 to the power of 0 plus 7 times 16 to the power of 1. That's 112 plus 2. You get 14 base 10. Next, we get binary to decimal. So let's go ahead and do the same exact thing with 100100. So starting from the right, I've been pointing, or I've been meaning to say, sorry. So pointing to the right side of the screen, we're going to go ahead and start with 2 to the power of 0. So we're going to do 2 to the power of 0 times 0 plus 2 to the 1 times 0 plus 2 to the 2 times 0. All the way down till you have them all out. And then you're going to get 2 to the 6 plus 2 to the 3. 72, base 10. Hopefully that listed all the means of converting. I didn't expect this to be like organic chemistry guy on YouTube's. But, I mean, hey, if it helps. If it helps, then there you go. If not, then I can just go back to dropping out of college. Alright, let's go ahead and end this video. Alt Z and stop recording.